we're going to look here at the percentage of an element within a compound, how that can be worked out. So remember that a compound is a substance which is made up of two or more different elements. So how much of, say, carbon is in carbon dioxide as a percentage by the mass. So how we do that is we take the mass of the element which is in the compound. So that is essentially the AR, the relative atomic mass of that element, multiplied by how many of that element there is, divided by the relative formula mass, the MR of the total of the compound, multiplied by 100. Now the simplest way to see this is probably by example. So we'll look at two examples here, which you could copy down in a set of notes. So first example, find the percentage of magnesium, oxygen, and sulfur in magnesium sulfate. So we're going to have to find basically three different percentages here. We're going to use this equation 3 times to find the percentage of magnesium, the percentage of oxygen, and the percentage of sulfur, which is in magnesium sulfate, MgSO4. So as we've already looked at, we can calculate our relative formula mass of MgSO4. And we do that by adding together the AR of each element which is present in that compound. So let's look at this then for MgSO4. So in MgSO4 we have one magnesium, and because magnesium has an atomic mass, if you look to your periodic table, of 24, we'll say it's 1 times 24, which of course is equal to 24. Do the same in this, we have one sulfur, so it's 1 times S. So if you look at your periodic table, sulfur has a mass of 32, so 1 times 32 equals 32. And for our oxygens, we have 4 oxygens. So we're going to do 4 times oxygen. Each oxygen has a mass of 16, so 4 times 16 is 64. Our total of all of those then is 120. So 24 plus 32 plus 64 is 120. So that is my MR, or my relative formula mass. So that is what's going to go into my bottom line here. But in terms of my top line, the mass of element in the compound, I have to look at the mass of magnesium, the mass of oxygen, and the mass of sulfur. But in fact, they've already worked that out by this method. So I know that the mass of magnesium is going to be 24. So to work out the percentage of magnesium is going to be 24 divided by 120 multiplied by 100. So we'll fill that in. The percentage of magnesium is equal to 24, which is my mass of magnesium, divided by 120, which is my MR, multiplied by 100. And if you put that into your calculator and work it out, that works out as 20% of magnesium. Now we can do the same thing then for the other elements. So for my sulfur, my mass of the element in the compound, I have 1 sulfur, so in 1 times 32 is 32. So my percentage then of sulfur will be percentage of sulfur equals 32. Okay, so the mass of the element sulfur divided by the relative formula mass, the MR, which is still 120 because it's still of the whole compound, the magnesium sulfate, times by 100, which then will equal 26.7% whenever you round it off. And lastly then, for my oxygen, the mass of the element for oxygen is 4 oxygens. So I don't just do 16 divided by 120, I have to do the mass of all of the oxygens. So it's still the 4 times 16. So it's going to be 64, which is my mass of oxygen in the compound. Because I have 4 oxygens, then I have to do 4 times the mass of 1 oxygen. So my percentage of oxygen, percentage of O, is going to be 64, that's my 4 times 16, divided by 120, multiplied by 100, which then will equal 53.3%. Now a good little check at the end, because that is everything which is present in the compound, that should add up to 100%. So just double check 20% plus 26.7 plus 53.3 equals 100%. So we know we've got that right. Okay, so that's example number 1. We look now to example number 2. It's the same process. Find the percentage of nitrogen, hydrogen and oxygen in ammonium nitrate. So my first step is to calculate my MR of my ammonium nitrate, NH4NO3. So I have 2 nitrogens, so that's going to be equal to 2 times 14, and 2 times 14 is 28. I have 4 hydrogens, so that's 4 times H, so it's going to be 4 times 1, which is the mass of each hydrogen, which of course 4 times 1 is 4. And then I have 3 oxygens, so that's 3 times 16, which is equal to 48. Adding all those together, 28 plus 4 plus 48 is 80. So that is my MR of my compound, or what's going to be on my bottom line. So to carry on as we did before, the mass of nitrogen, okay, is 2 times 14. So my percentage of nitrogen, percentage of N, is equal to 2 times 14, which is my 28, divided by 80 this time, because that's the MR of the compound, multiplied by 100, which works out at 35% of nitrogen. My percentage of hydrogen is equal to 4. So 4 times 1 divided by 80 multiplied by 100, which will work out as 5%. And lastly then I have 3 oxygens. So my percentage of oxygen is equal to 3 times 16, which is my 48, divided by 80 times by 100, which works out at 60%. Again, just that quick wee check to make sure everything adds up to 100. So 35% nitrogen plus 5% hydrogen plus 60% oxygen adds up to 100%. So that's a good wee check just to make sure that you have got your calculations correct. Okay, so in summary then, there are the 2 examples which are useful for trying to calculate the percentage composition of each element which is present in a compound. You may not always have to do every element. A question might only ask you to calculate the percentage of one of those elements. So it might only ask you to calculate, say, the percentage of nitrogen in ammonium nitrate. The process is the same. You still have to work out your MR. But instead of just doing these last couple of steps to work out the percentage of hydrogen, percentage of oxygen, you only would need to work out the percentage of nitrogen.